1965 famous conference, the London Bedford Colloquium, that saw actually the clash between Popper and Kuhn. The proceedings of the conference were published in 4 volumes, and the last one of these 4 volumes is fully devoted to a session in this conference in which Kuhn and Popper cross swords, so to say, discussing on the role of criticism and the role of dogma in science. Of course, Popper claiming actually the title of their original contribution was Popper's talk was on criticism versus dogma, and Kuhn's was dogma versus criticism. And Popper says in the paper that is included in the proceedings of that famous conference that a normal scientist dealing merely with puzzles and not with problems is someone we need to be sorry for. So this tells you about really the clash of approaches that is being displayed here. 2 really very different ways of understanding the nature of science clashing with one another. Some critics said, well, Kuhn and Popper are not really upholding contrasting views. Only Popper is focusing on the revolutionary moment, whereas Kuhn says, well, revolutionary moments are not that frequent. They are very rare, in fact, and most of the time scientists are working in a convergent as opposed to a divergent way. Well, it's more than that. The 2 positions cannot be actually reconciled. There are 2 opposing ways of understanding the nature of the scientific enterprise, and I shall say something about that later on. But just to clear a possible objection to that, there is no clashing between Popper and Kuhn because they are focusing on different moments, but they can be taken together. It's not actually the case. So anyway, so this is the nature of normal science. A highly, as Kuhn says, a highly convergent period of science in which the paradigm, that is the reigning constellation of theories, experimental results, methods, and so on, are never really questions, and are actually where problems are not real problems because we are assured by the paradigm itself that there is a solution. And so we are dealing with puzzles, and puzzles are not solved but dissolved, so to say, to refer to Wittgenstein's terminology, once we learn how to refer them to the paradigm itself. Incidentally, Kuhn's paradigm is very much in debt to Wittgenstein's view, especially his later views. We saw his view in the Tractatus Logico-Philosophicus, 1921, but after Wittgenstein's death, a number of his works, which were not actually completed, but they were published as they were left by Wittgenstein. And one of them, the Philosophical Investigations, talks about language games. That is, again, this focus on language and this idea that terms acquire a meaning only within a specific context, within or what Wittgenstein calls a language game, which is the language practiced or used by a form of life. So, for example, within a specific context in academia, for example, in the scientific community, some terms have a specific meaning, whereas the same terms outside that acquire other meanings. This idea of language game is the idea behind Kuhn's paradigm. Kuhn's paradigm are way more complex way more developed than Wittgenstein's language games, even though later on in his career, Kuhn went actually back to Wittgenstein's idea of language games. I shall say a few words about that later on today. But they are, as I say, they owe much to Wittgenstein. And indeed, just as language games are not the sort of things that can be true or false, so this is an actual quote, that is, we can question the truth of a statement within a language game, within that specific context, but we cannot ask whether the context itself is true or false. We have to take it as it is. Asking whether it is true or false, it does not make any sense in Wittgenstein's point of view. So a paradigm for Kuhn is the context in which everything gets its meaning, its function, and so on. So a puzzle is a puzzle only within that specific paradigm. But the truth, so to say, of the validity of the paradigm is never actually questioned until some of these puzzles resist our best attempts, the community of scientists' best attempts to refer them back to the categories of the paradigm. There are possible ways of dealing with these puzzles. We may simply wait for another generation. Maybe someone else comes up and is able to refer that puzzle to the paradigm, something that was not done before, but someone else comes up and does that. So that's fine. The puzzle once again disappears. Or else it's simply set aside and ignored. So there is this little thing here. It's not really important. We cannot think of a way to refer it back to the paradigm, but it's not really crucial. If we might come up with a way of doing that in the future, so let us ignore that for the time being and move on with our normal research. But, and this is the third possibility, if this puzzle is actually not a minor issue, it is actually a crucial issue. And if this puzzle resists the community's best efforts to refer it back to the paradigm from even on a prolonged time basis, different generations of scientists cannot come up with a, how can I say, with a plausible or with a strong way of dealing with this puzzle. Take, for example, the problem in astronomy of retrograde motions, the apparent retrograde motions of planets. This was a well-known problem, a puzzle, that was dealt with by Ptolemaic astronomy by introducing epicycles. But epicycles were not actually things that were to be found in the reality of things, in the reality of planetary orbits. They were simply mathematical fictions, mathematical objects added to the theory only in the attempt of coping with these retrograde motions. In order to explain those retrograde motions, the theory was not able to do so, so Ptolemy introduced elements to cope with these problems. And these elements were introduced, let me stress once again, only in view of solving those problems. So they were not a consequence of the theory, they were actually auxiliary hypotheses, so to say, introduced with the sole aim of explaining or accounting for these apparent retrograde motions of planets. By the way, this would be something forbidden according to Popper's methodology. Why? Because the Aristotelian picture of the universe had some consequences, allows for some predictions about the positions of the planets, and retrograde motions are not such predictions. So they should count, Popper would argue, as contradictions, as refutations to that model. So the theory needs to be looked at as a falsified or refuted. Whereas Ptolemy did develop the Aristotelian picture by adding elements that were added, let me stress once again, with the sole purpose of saving the original theory from a falsification. So these epicycles were not added were not consequences of the theory, but were added only to avoid falsification and to cope with the phenomena observed in light of a theory that was unable to account for the phenomena that were being observed. From Popper's point of view, the addition of epicycle was an addition of not an auxiliary hypothesis, that is a hypothesis that is later added to a theory, but which can be tested independently of the theory. But it was an ad hoc hypothesis. That is an hypothesis that was added to the theory with the only aim of preventing the theory from being refuted. So whereas auxiliary hypotheses can be tested independently and therefore do not diminish, do not lower the class of potential falsifiers for the theory, ad hoc hypotheses prevent the theory from being falsified, therefore contradict the higher rule, the rule saying that we should not allow for any theory to be saved from falsifications, and therefore the content of the theory, what the theory actually says, which from Popper's point of view equals to what the theory forbids, is lower. So the addition of the ad hoc hypothesis of epicycles actually prevents the original theory from being falsified. So it allows for the theory to survive, but at the price of lowering its content. This was Popper's point of view of this issue. How do we deal with, or how did astronomers deal with apparent retrograde motions of planets? In Kuhn's point of view, retrograde motions of the planet was a puzzle that resisted the community's best efforts to solve it, to refer it back to the original Aristotelian paradigm. So it was a way to deal with this puzzle, but not a satisfactory way of doing so. So the third option, when dealing with puzzles, is that the puzzle poses a serious question to the paradigm. So it may be set aside for some time, maybe some ad hoc hypothesis is introduced to account for it, but it's still there. It cannot be ignored because it is crucial to the paradigm. And to repeat, the best exponents of the scientific community are unable to satisfactorily deal with it. So in this case, Kuhn says that puzzle changes its status, so to say, and becomes, and that's another key term introduced by Kuhn in the Structure of Scientific Revolution, that puzzles turns into an anomaly. An anomaly is a puzzle that resists our best efforts to refer it back to the paradigm for a long time by the best members of the scientific community. And it's not something we can actually ignore or set aside. So when a puzzle, or more than one puzzle possibly, turns into an anomaly, that scientific discipline enters what Kuhn calls a crisis. So the paradigm, the very paradigm that defines that normal period of normal sciences enters a crisis. So during a crisis, as opposed to during a period of normal science, the paradigm is directly challenged, is put into question, which does not happen, to repeat, during periods of normal science. So when a scientific discipline enters a crisis, the paradigm gets challenged, gets questioned by its very supporters, and we go back to something similar to what happened during pre-paradigmatic or pre-scientific periods. Namely, a number of alternatives are advanced in order to cope with or to account for the anomaly, to explain the anomaly. So we have, in a period of crisis, or in the period, as Kuhn says, of extraordinary science. Extraordinary simply means not ordinary, not normal science. We have different competing theories, or in Kuhn's terminology, paradigms, to deal with that anomaly, or with those anomalies. And once we deal with different positions, one of them turns out, after some time, after some tests or whatever, sometimes to prevail over the others. So a scientific revolution, in Kuhn's terminology, takes place when a new paradigm, which is one of those that were competing with one another in a period of extraordinary science after a crisis, when again a single paradigm prevails, because it is more successful than others to cope with that anomaly, prevails over the other, then we have what Kuhn calls a scientific revolution. Therefore, a replacement, that is a replacement of the old paradigm with a new paradigm.